In this third demo, I'm going to show what kind of information we can get from a model that has end-to-end flow instances. So here I'm loading up a model. This model has two end-to-end flow instances. And first we're going to take a quick look at the software model. Here you'll see all the logical connections. So logical connections can exist between devices and also between thread and devices as well. So here's the software model. And now we'll check the end-to-end flow that exists in the model. So as I explained before, end-to-end flows consist of multiple connections, and in between connections we have flow paths. So these flow paths are actually can be used to represent execution time. So let's say that somebody wants to check the end-to-end flow and make sure it's within some value. So if you run the analysis, it's going to estimate the average delay depending on the bus speed and all the data that shares it. So right now we don't have that many flows, so we have very small delay values, but you get it for each connection, and then it's going to sum it up and give you the total end-to-end delay for the end-to-end flow. Now, these flow path, you can always save a value here which represents, say, the execution time for handling the data. So anytime you measure your system, you can always overwrite. Even for the connection delays, you can overwrite the value that you've gotten, and then if you run the analysis, it's going to use that overwritten value. Also, you can store any kind of latency assumption or requirements that you assume about the model, and it'll show you how much the latency percentage is compared to that requirement. So here you can see the periods of the connection. So for more detail of the connections that exist in the model, you can load it up in the bus delay analysis. So using the connection ID, you can find the one that you're interested in. Also, for the end-to-end flow analysis, we have a graphical view of the network. Fix this. So here you're able to see the network, the hardware model. So this is the hardware model, and then for each end-to-end flow, you can see, identify or recognize how the data is moved around. Okay. And another thing is you would be interested in bus utilization. So if you move to the bus utilization info tab and then run the renew utilization, it's going to show a table of all the buses that exist, and compared to its bus speed, how much of it is utilized. If you're interested in the connections that goes in through the bus, you can always extend the bus to see what kind of connections are giving it any kind of load. So here you'll see the connections and also the period of the connections, uh, how much delay it's experiencing for that bus component. So this ends my third demo, and I would like to say that this is what I show here is only recent changes that additional functionalities that we've added to ASIIST. Previously, it supports schedulability analysis and bus delay analysis, and most of all, it supports IMA systems. So if you have a IMA system model for the hardware, then it you know lets you assign applications to partitions, and then also show for the bus utilization, it'll actually partition the bus so that it'll give you information about at each partition what kind of connections exist in the system. Thank you very much, and bye bye.